it's an odd exponent.
Yeah.
All right, so now how do I determine what my factors are? The rational root theorem. And the rational root theorem tells me what are my roots? How do I find my roots? Okay. The constant term is what?
45.
45. So what are the factors of 45? 1, 3, 5, 9, 15, and 45. Does everybody see where she got that?
Yeah. Yes.
Okay. And what goes on the bottom?
1.
Yeah, the leading coefficient. So essentially I don't need to do this because the leading coefficient in 1, these are all going to be plus or minus numbers, right? So they're all going to be whole numbers. Any questions about that? So now all I have to do is I have to go through and I test this. And I have to test each one using synthetic division on this. And then once I get one of them, then the answer is going to fall out the bottom, and then I'm going to have what type of problem on the bottom am I going to have? Because it's an x to the third, so when I factor and I find one factor, what's going to be left? Yeah, it's going to be a quadratic trinomial. It could be a quadratic binomial, but it's going to be a quadratic. And that way, once I get a quadratic, then I can use the x, or I can use grouping with tricky trinomials. Or if it's a quadratic binomial, I can use difference of squares. And I have to figure out what my factors are. Does that make sense? So does that help you understand how to approach these types of problems?
Yeah.
All right, so the answer was C, x plus 7. And I'm not going to go in and do it, but if you're copying this problem down, and you know the answer is C, then you can work backwards from there to go back and look at it at home. Okay?
I have a quick question.
Yeah.
So for the ones over there that 1 over 1 and 3 over 1, shouldn't x plus the square root of 5, shouldn't that be one of the listings up there?
No.
No?
No. These only give you, what do these tell you?
Those tell me
The possible roots. It doesn't list all of them, but it gives you the possible ones. And again, if you've got imaginary roots, will they show up on this list? No, because there's no eyes up here. So there may be some imaginary roots that aren't going to show up, right?
So only a few show up there.
Only a few show up, but that gives you a place to start.
Yeah, okay.
And that's the key, is to knowing where to start to help solve the problem. Does that make sense?
Yeah.
All right. Let's go to a different problem. I want you to divide this using long division. Now, the first thing you look at, I want to give you guys a quick hint. The first thing you should look at when you see a problem with long division, what should you look for? Automatically. Before you start division.
The terms, like if they go on, right?
Yeah.
X cubed, X squared.
Yeah, you want to make sure that the terms, there's no missing terms. Like 3, 2, 1, 0, okay, all the terms are there. But what if I had like x to the 4th plus 4x squared? Yeah, I'd have to put a 0x cubed in there so that I've got a place for those things when I'm solving the problem. Does that make sense? And it goes the same for the divisor. If this was x squared plus 2, what would I have to divide by? If this was x squared plus 2, I'm just giving you a for example. If this said divide it by x squared plus 2, what would I need to divide this by in long division? X squared plus what? 0x plus 2. Perfect. Does everybody understand why you do this? Hmm? Any questions? Okay, so it's not x plus 2, so we're just going to go ahead and do this one. So go ahead and do long division and tell me what your answer is.
Yeah, I got it.
What?
When you get a solution, raise your hand. I want to come check. Perfect. Good. Oh, you just started. Never mind. Sorry.
What? You just have to go to the left.
Good. 2x squared minus 2?
Right.
Yeah.
So, minus was just 0 times 2, would it also be equal to 1?
No, you don't, when this is 0 like that, I'll just put it on the next one.
Oh, really? Oh, okay.
Yeah, you don't have to do that. All right, so you should have gotten 2x squared minus 2. Who got that? Raise your hand. Good job, guys. Most everybody that was working this, you guys did it just perfect. If you didn't get 2x squared minus 2, what you need to do is write that answer down, make a little star, and then later on go back and check and see what type of mistake you made. Okay? Just go back and check your work to see where you made a mistake. Now that you know what the answer is and you know how to get there, go back and see where you made your mistake. All right? Let's do another one. All right, I want you to find all of the factors of the following polynomial. Now again, this is just like what we've been doing for which of the following is not a polynomial. So what should the first thing that I should do? What's the first thing I should
add
do?
an x squared. 0 x squared, add a 0 x.
Yeah, if you're going to do any type of long division or synthetic division, you're going to have to add in the x squared term. That's right. But before you do that, what should you do? Find out what the possible roots are, right? So you know what to test. So what are the possibilities that I'm going to test with this?
2 and 1.
Yeah, plus or minus 2, plus or minus 1. And according to Descartes' rule of signs, how many positive real roots am I going to have?
3.
0.
Wait, what?
Descartes' rule of signs says you're going to have to go and you're going to have to count the sign changes. Is there a sign change from here to here?
No.
Is there a sign change from here to here?
No.
What does that tell you? That means there are 0 positive real roots that we're going to check. So if I'm checking positive and negative 1, or positive, what are my roots again? Positive and negative 1, and positive and negative 2. By looking at Descartes' rule of signs, I've just eliminated half of my testing, or haven't I? I don't need to test the positives, do I? Yeah. And what's that? Well, let's see. What is the negative?
Negative x cubed.
Negative x cubed.
Minus
Negative x. No, you can't. How do you change the 2? How can you change that with a minus x?
Can't, because there's no
You
X.
can't, because it's no x. So there's a plus 2. So how many negative roots do we have?
Who knows?
1. So again, using Descartes' rules of signs, I've eliminated having to check plus 1 and plus 2. So that only leaves minus 1 and minus 2 as a possible root for this thing. So do you see how Descartes' rule of signs can help you? A lot of times people think, oh, Descartes' rule of signs, it's a quirk. You know, why do I need that? It helps you eliminate possibilities. And in this particular case, I don't need to test my positives, so I've eliminated half of my things I need to test. All right, so what did somebody get?
Negative 1.
You got a negative 1?
Yeah.
And
X squared
what's the
minus
other one?
X plus 2 and x plus 1. Those are factors.
What's that?
Parentheses x squared minus x plus 2 parentheses. And then parentheses x plus 1.
Okay. So this was a case where I wanted to show you guys why you want to use Descartes' rules of signs. Does it make more sense to you now as to why you want to use it? It's a very useful tool to have in your arsenal when you're approaching problem solving, especially when you've got a whole bunch of roots. It'll help you reduce the number that you need to test. All right. Let's go to another. Oh. What was that for?
What?
What was the first one? Huh?
You did that on purpose.
I did that on purpose.
Yeah.
So what was the root for this question? What did you come up as a root?
Negative 1.
Negative 1. So let's do the synthetic division with negative 1. So there's a negative 1, and I get a 1 here. 1 times minus 1 is minus 1, 0. 0 minus 1. What did I do? Did I do something wrong?
It must be -2.
Oh,
Oh,
it must be -2. Well, look. 1 times -1 is -1.
Oh, I know.
Minus
You forgot
1
to put
plus
X
1 is
squared.
0, right?
You forgot to put x squared.
there's no x squared.
Oh, that's right. Good catch. Nobody else caught it.
Oh, yeah.
Maybe that's why you were having problems factoring it, huh? So let's go in and rewrite this thing so we can do it in synthetic division. And again, if you forget that, that's a perfect example as to why you need to be careful. Does that make sense?
Yeah.
Sneaky, huh? Was that? I snuck that in on you. I want to see how many people got it. So here we go. X to the third plus 0, x squared, plus x plus 2. Now let's see if it works. I bet it will. -1. So there's 1. 1 times -1. -1. -1. 1 times -1. Plus 1. 1 plus 1. 2. 2 times -1. -2. There's one of my roots. Now what's the next step I have to take?
You have to take
So I go down here and these are my coefficients, right? So what do I write?
x squared
X squared
1x
minus x
plus 2.
plus 2. What are my factors? Can you do it like this? Let's see. Plus 2. I got a -1. What do I get? -2 and 1. Let me see. -2 times a +1 gives me a -2. That doesn't work.
Yeah, I don't know. It won't find it.
It won't factor. That's perfect, Egley. It won't factor. So, what would you use? Now, if you can't factor it, what are you supposed to use?
Quadratic.
Which is why it flashed up on the screen just a quick. You have to use the quadratic equation to solve this. So when you use the quadratic equation, did anybody come up with a solution? Do you remember how to use the quadratic equation?
No, show.
Plus or minus.
All right.
There's plus.
So does everybody understand that you can't factor this? I want to make sure everybody understands you can't factor it.
I got it.
Yeah.
All right, so let's go through the quadratic equation. First of all, somebody tell me, what is the quadratic equation? Yeah, Lillian?
Negative b plus or minus the square root of b squared minus 4ac divided by 2a.
Oops, I'll make those lowercase. AC over 2A, right?
Is this
So what does A equal? Thank you. What does B equal? -1. What does C equal? 2. Does everybody see where I got those numbers? All right, so all I got to do now is plug it in, right? So here we go. X is equal to minus B. Well, minus a -1 is what?
Positive.
1. Then I got plus or minus the square root of. What's B squared?
-1.
B squared
Oh, B squared.
1.
is 1. And what is 4 times, minus 4 times A?
What?
Minus 4. Minus 4 times C?
-8. -8.
Yep, minus 8. So 1 minus 8. So what is, and all over 2 times A, which is what? 2. All right? Everybody with me to there? Yes?
Yes.